Tell me, can you hear me or can't you hear me? Unless you speak out, how will I know whether you can hear? Oh, great. Please do one thing. We will wait for 2-3 minutes. Ask your other friends also to join in, so that we have few of you at least who join in. Ask your other friends to join so that we can begin our session. I shall wait for 1 or 2 minutes so that you can ask other friends to join and we can start it off together. This is the last code which we had written for you. Am I correct or wrong? Tell me, please. The last thing what we had written and executed is this in your last session. Because I maintain a record of what you do. For the reason, that's why I could just open it blindly. And this is the last one which we had done. Kindly confirm. Tell me, tell me. Razak, Sayeda,
Yes, sir.
tell me.
This
Yeah,
was the
okay.
last one. Yes.
Yeah, we will continue from this same point onwards where we had left off in the last session, so that we may, and kindly, even if you open the code, please execute all of them. Otherwise, your the thing what you write ahead of this will not be executed. You will not be able to run it. So in this, what we did, we what is that? Let me just go through this. We had used this transformer mix-in. Okay. Okay. Yeah, we had used this transformer mix-in, which is a small transformer class that adds the combined attributes, like what we had done earlier to this. So we had used this transformer mix-in. And now to wrap up this concept of what we had done using this transformer mix-in, we have to find out or we have to find out the housing extra attributes. Which did we list it out over here? Yes, we have listed out the housing extra attributes. Now, after this, what you need to do, see, you need to do, what is that you do with this data? You do the feature scaling of this data. That is, which is one of the most important transformation you need to apply to your data, which is nothing but feature scaling. See, these MLAs, that is machine learning algorithms, don't perform well when the input numerical attributes have a very different scale. And this is the case, the same thing in this housing data. Please do one thing. One of you, please open up this housing data and see this total number of rooms column. What range to what range are this? Just a casual glance. Can you open up the CSV file and see it? The original housing data which has been shared with you. Just open up this housing data and see how many are there in the total number of rooms. See, here we have got total rooms. This column, just see how many total rooms are there. What is the minimum value? What is the maximum value? Get glance. Something, it starts from some single digit to around 40,000, 39, 40,000 it's there. That's what I remember. And definitely I'll also request you, please see the median income. What range does it range from? That also ranges from, I think, about 0 to 14, 15 or something. See, now scaling the target values generally, you can say, not required. There are two common ways to get all attributes to have the same scale, which is this min-max scaling and standardization. This min-max scaling, which is also called as normalization, is the simplest. Values are shifted and rescaled so that they end up ranging from 0 to 1. And how do you do this? You do this by subtracting the minimum value and dividing by the maximum minus the minimum. So what does Scikit learn do? It provides you something called as min-max scalar. And this min-max scalar has a feature range hyperparameter that lets you change the range of it for some reason between 0 and 1. But please understand, this concept of standardization is different. First, what it does, it subtracts the mean value and then divides by the standard deviation so that the resulting distribution has a unit variance. See, unlike this min-max scaling, standardization does not bound values to a specific range, which may be a problem for some algorithms. How by outliers. So since we said this is much less affected by outliers, we have to Scikit provides a transformer called standard scalar for standardization. But you have that all others, all the transformations, it's very important to data only, not to the full data set. Only then can you use them to transform the training set. As you have seen, there are many data transformation steps that need to be executed in the right order. But to take care of this, Sky learned providing what is called as the class pipeline with sequence of transformations. So what we do, we create a simple pipeline for the new variables, new attributes. So how do we create the small pipeline for numeric attributes? Instantly, you can say anything because you are just 5 hours a day. Tell me one thing, haven't you done machine learning in your college? Have you done this machine learning in your college?
So we did not go through machine learning in our college.
No machine learning. Then when do you learn this?
No.
Machine will eat you up then. Oh, it is.
It's last time 4-2.
Sorry,
It's
Razak.
4-2, sir. We are in 4-1. Sir, we are in 4-1. Machine learning is in 4-2.
What is this 4-1 and 4-2?
Fourth year, first semester, sir. In fourth
Okay,
year, second semester, we have machine learning, it seems.
but being very frank with you, more than 96-97% of colleges in whole of India, they don't cover this. But rightly, it has to be covered, which is extremely essential. Extremely essential. I don't know. Venice said that all these things would improve. Okay, fine. So see, our aim is we are doing our predictive analytics, which we are predicting the house price and which are along the seashore in California. So we said, and these are all the steps that is required. We are doing a complete project in biomachine learning. And how many of you who are present here, the small number, do you find all these things difficult, or don't you find it as part of what you have learned? Don't you find it simple? Tell me. Saida, do you find it
Usually we
simple or is it
practice it more
difficult?
than 2 to 3 times, sir. Otherwise, we'll
Oh,
feel it difficult if we don't practice.
but when you get to hear all this, do you find it difficult?
Just a
Let
little,
me.
sir, but we are able to cope up, like, somehow.
Okay, but that is a good something good which you said. Please understand, there are people, engineers, who have completed all 8 semesters of engineering from good college. They are with me for last 3 to 4 months, but still they have not been able to follow. How do you write all these things? It's a wonderful trick. How do you write all these things? Okay, let's continue. We said that we will create a small pipeline for the numerical attributes. How do I do it? I would say from, I hope you are writing it or you're just listening to it, what I'm doing. Sohail, Saida, are you writing it or just listening to what I'm saying?
No, sir, we are doing along with you.
Okay. So from sklearn dot pipeline, I will import pipeline. Now I need to also import the standard scalar, which is also part of this sklearn library. So I'll say from sklearn dot preprocessing, I will import standard scalar. Now I create my pipeline with 3 attributes: imputer, attributes adder, and standard scalar. So I say num underscore pipeline, which is nothing but my pipeline, which I would say is the first is I consider my imputer, which is nothing but my simple imputer with the strategy which I take as median, because replacing with the median value is far better rather than with mean or mode or anything. The second is I take my attributes adder, which is nothing but my combined attributes adder. And now apart from this, what do I need to take? I need to also take my standard scalar, which is nothing but my standard scalar. This is my standard scalar. So after this, one second, what I will do, after my brackets, I give a comma. Now what I will do, I need to now find my housing numerical attributes. So I say housing underscore num underscore tr, which is nothing but num underscore pipeline dot fit underscore transform of this housing num. I say of the housing num. So when we execute this, oh, it says combined attribute spelling, combined ADDER. It's a spelling mistake. Wonderful. So we have now, when I want to find out what is my housing numerical attributes, just call this back. It gives me a simple array, which is nothing but a simple array of everything which I've got as my housing attributes adder, or this numerical tr. You can do this. In the meanwhile, let me get a bottle of water, because continuously since 10 o'clock, something or the other is going on, either some session or some meeting or something. Let me get a bottle of water, please. Okay, done till here. Confirm, please, if you're done till here.
Yes, sir, done.
Okay, here this pipeline constructor, it takes a list of names and this estimator pairs, defining a sequence of steps. Now all but the last estimator must be transformers. That is, they should have this fit underscore transform method. You can just see earlier, see here, it has to be a transformer, which see in this 44 of mine, the last one has to be a transformer with the fit underscore transform method. The names can be anything which you want, as long as they will come in handy later for this hyperparameter tuning. Now, when you call the pipeline fit method, what does it do? It calls the fit underscore transform sequentially on all the transformers, passing the output of each call as the parameter to the next call until it reaches the final estimator, for which it calls the fit method. This pipeline exposes the same methods as the final estimator. And in this example, the last estimator what we have used is the standard scalar. The last estimator what we are used is this standard scalar. Is this time? Last estimator is the standard scalar, which is a transformer, so that the pipeline has a transform method that applies all the transformation to the data in sequence. Now, till now, we have handled the categorical columns and the numerical columns separately. But tell me, won't it be wonderful if you're able to handle both of them at the same time? So instead of writing last about 5-6 of the, in fact, I'll tell you, instead of writing what you wrote from 44 till 59, you can replace this whole thing just with a small bunch of code where I'll call the column transformer, which takes care of both the numerical as well as the categorical attributes in any data set. So I'll just call this column transformer, and we will take care of both the numerical as well as categorical attributes of this data set. So I'll say from, let me import it first. So from sklearn.compose, I will import column transformer. Then I specify my numerical attributes as the list of my housing and housing number num, and in the same thing I'll specify even my categorical attributes. Let me take the variable as cat attributes, which is nothing but my ocean proximity, which is my the only categorical attribute which we had over here. Now this whole thing I'll create a full pipeline. So I'll say full pipeline is column transformer of, let me take both, that is the numerical attribute, which I would call it as numerical pipeline, and the numerical attributes. And then I would also take my categorical attributes, and this will be, you please remember, to convert a categorical attribute to a numerical attribute, you use a one hot encoder. So I'll call this one hot encoder, and I would say my cat attributes and a comma. Now I would just call my housing prepared. I would just say my housing underscore prepared, which is nothing but my full pipeline dot fit underscore transform of my housing. Now what you do, you just call back this housing prepared, see what you're getting. I'll call back this my housing prepared. I will get the exactly the same array which I got in 49. That is, the array which I got in 49 is exactly the same what I get here. Very close, not maybe very few decimal places here and there, but it is more or less the same what you got. So rather than doing it separately, it is any day better using this column transformer and hitting at the problem. So kindly you may write it, let me know after you've done it, so that we can go ahead together. And when you write it, please try writing it with comments. It will help you when you want to do it later. Anytime you open it, it will make some sense to what you have done.
Excuse me, sir.
Yeah.
So what was it? What was it that you said about one hot encoder?
See, one hot encoder is something which converts the categorical variables to numerical variables.
So why are we converting? So why can't we
Tell
take it
me one thing.
directly?
Yeah, see this. I'll now take you back to the first data set which we had. See this. See, when we roll up this one, see in this data set which I had, this is my original data set, this housing. Here, everything is numeric variables except this ocean proximity, which is the only categorical variable. Now, if I want to find out some, say, mean, median, mode, or any IQ or interquartile range or anything, I want to do any computation, how can you do it for a categorical variable? Can you do it, Saida? Tell me. You cannot do anything
No,
for
sir.
category.
Yes.
Can you find the mean of some A, B, C, D, or E? You cannot do it. So I have to convert the categorical variables to numerical attributes. But please understand, this problem that we're doing is very, very simple, for the reason that there is only one categorical variable. The problem generally which you find in real time is not like this. It will be totally different. It will be totally different. So good that since Saida asked me a small, your next assignment, which I'll upload today on your canvas, please listen to it very carefully. The thing is, see, it was 3-4 days back when I was involved in conducting a session for this Omani nationals. One of the person told me, why don't we do some real-time project? Because more or less, because he said our head is totally cluttered with all these concepts, some pipeline and some transformer and one hot encoder, column transformer. It is because headache. Let's put it into practice. The same day I called up one of my friends who is working with Zomato in Bangalore. I asked him, give me a problem, we will solve it for you. He at the same time told me a problem, same time. And it has just been 2-3 days. Yesterday, till very late in the night, I sat, I finished, I solved it, completely solved it. This is the same problem I wish you guys to do. Are you willing to do it? Tell me, Saida.
Yes, sir. We'll give it a try. Definitely.
See, your problem is you have to see, Zomato is a food delivery app. Along with Zomato, there are so many food delivery people who operate in Bangalore and definitely even in Hyderabad. So what you do, either you can take Zomato or maybe Swiggy or whatever as the benchmark, compare the performance of all these food delivery app, considering various attributes. That is, you have to compare the ratings of all these chaps. To compare the rating, a lot of things come into picture. One is how fast the food is delivered, and how many complaints are there when the food is delivered. Then how pleasing are the people who come to deliver food, or how pleasing are the people who take your order, and various other things, whether the food which comes to your house or at your delivery place, is it hot, and how many other times that the food has come late. Many of these factors, whatever you find, no data set, nothing was given to me. Similar to you guys also, no data set, nothing. Solve the problem. But since this will be the first of the live problem which you will be doing, my suggestion is, don't worry, don't take it as an assignment. Today being Thursday, try it out till say maybe Saturday. That is the day after tomorrow. If you are able to do it, wonderful. Which I would say is difficult. Try. If you get stuck somewhere or otherwise, one of you give me a tinkle on this Sunday, sometime maybe, because I've got my sessions till about 2 o'clock. Around 3 o'clock, give me a tinkle. And around 3 o'clock, give me a tinkle. And the same time, in 5 to 10 minutes, we will get onto a video call and we will solve it for you. How do you solve it? You will know it, because it's wonderful when you solve a real-time problem. At that time, you'll realize that all these things what you learned comes into use over there. All these things. See, for now, the problem that we are doing is the housing problem, or the California housing problem. You may not be able to perceive it that clearly, because you feel what difference it makes whether the house is near the ocean or it's not near the ocean. Makes no difference. Fine, get into a real-time problem, real time problem. But before all this, I actually expected you guys to ask me one small thing. See, whenever you do machine learning, there are various ways by which you can do, and practically various ways by which it is done in the industry. The first way is what we are doing. This is scikit-learn. Extensively I'm relying on scikit-learn. The next way, or a competing library with scikit-learn, is TensorFlow. When you do using TensorFlow, see in scikit-learn, you find lot of inverted commas, lot of underscores, lot of commas, lot of headache. It's a confusion. I really agree, scikit-learn is a confusion. But when you do using TensorFlow, all these things are not there. The approach is totally different, but the results are the same. That is also very, very powerful library, TensorFlow. You got around 14 libraries by which you can solve any of this machine learning problem. You got Lasagne, you got this one, that is you got scikit-learn, you got TensorFlow, you have got Lasagne, then you have got Keras. You can do it with Apache MXNet, you can use Cafe, you can use Rust, you can use Theano Python, you can use Microsoft Cognitive Toolkit, you can use PyTorch, you can use Eclipse, you can use NoLearn, you can use PyLearn 2. All these you can use to solve whatever problem you're doing, anything in machine learning. But extensively, as on today, what is the most preferred is scikit-learn or TensorFlow. 100% of problems you can solve. It is humanly impossible that all these things what we are doing in scikit-learn, we again repeat it using TensorFlow. The approach is totally different. The approach to solving problem is totally different. But if you feel you want to do really good in life, you want to do a big job, not just this marketing or anything, you have to learn, either you have to excel in this field. For you to excel in this field, definitely I would expect us one of these days, before your course gets over, one of you call me up and tell me, I will tell you what is machine learning, rattle out a lot of algorithms, tell me end to end of what it is. It'll be a real pleasure to listen to you, that you're picked up, you're become. But understand one thing, as on today, there are just a handful of people who are good in machine learning or deep learning. It is very, very difficult. It is not difficult, it is very, very difficult. That is why majority of engineers prefer marketing, because it has got nothing technical in that. To do marketing, why should you do engineering? Just 10th standard is more than enough. Not even 10, 6th standard is enough. Okay, let's leave that. That is not our job. So what we did, we have found out this housing prepared
So,
using this column transform. Yes, sir.
sorry, before we proceed, one small silly question. You said about this assignment thing, no? So if we don't have the data set, how are we going to do it? We need to form the data set.
No, see, please understand, when you solve a real-time problem, nobody gives you data set. Nobody, and nobody. They tell you, assume whichever data set you want. Now, then the big question comes. See, now the question which you ask, either where is the data set? This question is to be asked by some first or second standard child. Because if I give you everything, I can only do it and give it to you. Why should I tell you what is to be done? From wherever you want, you collect it. So I'll use the word wherever you want. Anyway, and it is not easy getting the data set. You cannot say okay, and it is not easy. It is really not easy. You will have to break your head to get the data set, and then you form up the problem. I would suggest try it out till this Saturday evening. If you're not able to get it or get a clue of how to solve such real-time problems, give me a call on Sunday somewhere in the afternoon, because morning you call, I may not pick up. I have a very intense session for the DRDO and Bharat Electronics Limited employees in data science. So until about 1:30, I won't be able to pick up your call. After that, when you can call me anytime, maybe after 2:33, you call me anytime. So we will sit down, same time, solve it for you, so that you understand how do you solve this and where is that these algorithms come into picture. At that time, you'll realize what you have learned, which one you place where, which algorithm you use where is extremely essential. It's like this either. See, before you start speaking in English, why is it that in class 1 and class 2, they teach you all alphabets, the meaning, singular, plural, all these things? It is for the reason that when you frame your sentence, you need to be perfect. You really need to be perfect when you frame your sentence. So at that, they give you all the foundation so that your English is perfect whenever you frame sentence and speak at a fast pace. So at that time, what you learned in English makes a big difference. Similar is the thing. I am helping you with all the fundamentals, but little on the higher side. See, today in engineering, you're in third year, fourth year, or whatever, and you say it is too early for you to learn this, you're mistaken. You're too late to learn all this, I'll say. Because see, Saida, I'm also involved in training the working professionals at the United States of America and also at Australia. I know what is the standard, what is that they learn, the way they demand things, the way they want to know whatever. They call me at 3 4 o'clock in the night. They want some concept to be clarified. They just tell very politely, they tell Dr. Suresh, we are very sorry, we just want to have this doubt clarified from you. Great. Although I feel it's a trouble for me, but okay, I feel at least the amount of interest which these guys are showing is phenomenal. That is what is required. See a good example. Today's session, not more than 6 7 of you are present. See, for me, it makes no difference. For me, it's just completing the syllabus, and I want to be justified in completing it. We will do it the proper way without skipping anything. Whether 6 7 or 60 of you or even one person is present, we will complete it. Okay, chalo, let's come back to what we were doing. See, in this, this one hot encoder which I used here returns a sparse matrix, while this num underscore pipeline, which I have used over here, this num underscore pipeline, this num pipeline returns a dense matrix. See, when there is such a mix of sparse and dense matrix, this column transformer estimates the density of the final matrix, that is the ratio of non-zero cells, and it returns a sparse matrix if the density is lower than the given threshold. So in this example, it returns a dense matrix, and that's it. What we have done, we have a pre-processing pipeline that takes the full housing data and explains the appropriate transformation to each column. Now, if you are using, say, anything earlier than scikit-learn 2.20, you can use a third-party library such as this. Pandas also provides you a library, and you can roll out your own custom transformer to get the same functionality as this column transformer which we have used over here. Now, I would say we are at bang on place where we can learn and select a model. We can select and learn, select and even definitely train a model. So to train this model, I would say before we even get into this concept of training this model, let me see using this transformer mixin, what kind of output will I get? Because we just now mentioned that we can also use this transformer mixin, but this way of using this transformer mixin is a slightly older way. No problem, we will use that and see how do I get my output. So once again, I need to import this transformer mixin, which is once again a part of sklearn.base. From sklearn.base, I import base base estimator and transformer mixin, and I'll create a class to select the numerical or categorical columns. So the class that I create, I'll say class old data frame selector, which is of my base estimator and transformer mixin. Making this conditional, I will define three things: my initial value, the fit, and the transformer class. And then what we will do, we will run this old numerical pipeline and get ahead going with this data. So this is basically a little older technique of solving it. I thought let me show it to you. So I'll define init, which will be my self and my attributes names. Will make this conditional. So I would say self dot attribute underscore names would be nothing but my attribute underscore names. Now then I will define my fit also with this. So I'll say define my fit, which is of myself and x and y as, let me take it as none. Make this conditional and we will return self. The third class I define is the transform class. Third I define is the transform of my self and x. making this conditional, and I will my return x of my self dot of my attribute name dot values. Let me try this. Fine, great. Now we know our only categorical attribute is ocean proximity. So I will define my numerical attributes and categorical attributes separately and run the pipeline on this. So what I'll do, I'll say num underscore attributes, which is nothing but the list of housing underscore num, and my categorical attributes will be it will be my ocean proximity. Now I would now define my old pipeline for this whole set of data. So I'll say my old numeric, first we start with old numeric pipeline, which will be nothing but my pipeline of I say my selector, which is old data frame selector of the numerical attributes, and also I will take my imputer. I will say my imputer, which is nothing but my simple imputer with the strategy what it is any day imputing, that is replacing the missing value is better if I use median.
So
So that,
attrib spelling.
where is it? ATTRIBS, correct? Oh, RI,
Old
okay,
data.
okay. Attributes, okay, no problems. Last it will tell me where is that I've gone wrong, we'll correct it then. Then what do? I take the attributes adder. So I say attributes underscore adder, which will be nothing but my combined um, combine attributes adder and a com, and then lastly we need to take even the standard scalar. Standard scalar, which is nothing but my standard scalar, and I give a comma. Fine, this should be my old numerical pipeline. Let me try this. Oh, there is some old data frame selector is not defined. Just a minute. Old data frame selector is not defined. One second. Old data frame selector or numerical attributes. Old num pipeline is this. Old. In fact, let me make this. Oh, 1 second. Combined at spelling of attributes. RIBUTES, attributes adder. Yeah, wonderful. Now this is for the numerical pipeline. Similar way, let me create it for the categorical pipeline. So for the categorical pipeline, this will be my pipeline of my selector, which will be my no, I'll not take the selector, I'll just take the category encoder, which will be nothing but my one hot encoder. This time I don't want a sparse matrix, so I say sparse equal to false. So after this, give a comma. Let me try this. This is fine. So here till here you may kindly write down, let me know so that we do the remaining thing after this.
Let's continue, sir.
So where we will now, I'll now call upon the feature. Basically, why are we doing all this, which I've done from 51 of mine? It is for the reason that I want to show that this older technique is more or less the same like what we have done with column transformer. So a few more lines just to prove it out. I would say from sklearn dot pipeline, I will import my feature union, and I would define my full pipeline as old full pipeline, which will be nothing but my feature union of this transformer underscore list, which will be nothing but the list of my numerical pipeline, that is a numerical pipeline, which is nothing but my old numerical pipeline. And apart from this, I need also to call my categorical pipeline, which I would say my cat pipeline, which is nothing but my my old underscore cat underscore pipeline. Give a comma, and this, let me execute this. Fine. Now what I'll do, my old house, let me do a transformation of this old full pipeline and see what is the old housing that I'm getting, old housing data. So I will say
So up there, old spelling, old full pipeline. It's OLF.
oh, sorry, I'm bad in typing, Saida, because I don't look at the keyboard and type. I don't look at the screen and type. I look at the keyboard and type, so that I don't want to miss out something. I'm not a typist for me to do such kind of typing. Okay, so I'll say my old housing prepared is nothing but my old full pipeline, and here I will transform this. So I'll say fit underscore transform of my housing. And when I call back my old housing prepare, let's see what I get. Oh, 1 second. Nearby could not convert string to float nearby. I'll tell you what is the reason for this. This is because we knocked out this categorical variable. When I call this categorical attributes, I didn't use this old data frame selector. That is why it is giving me trouble. So once, what we will have to do, go back 2 steps and transformer mix in old data frame selector. In fact, I'll copy the same thing so that there is no ambiguity in what we are doing. Here, the first one, I'll give it as my selector, which is my old data frame selector of the numerical attributes. Let me try this. Oh, 1 second. Name, attribute name is not defined. Okay, so this is simple imputer, strategy, median, combine attribute adder, combine attributes adder, standard scale. This gives me error in the first one. Numerical ATT RIBS selector. A selector, it gives me attribute names is not defined. Old numerical pipeline is my pipeline of selector, old data frame selector, numerical attributes, and imputer, which is simple imputer, strategy, median, and attributes adder, combine attributes is adder, and standard scalar, which is the standard scalar. Attribute name not defined. Self attribute name define init. See LECT or selector. It is not able to find the selector. What do we do for this? Ocean, 1 second. Ocean proximity. It's just got to do with some spelling mistake somewhere. Selector, old data frame selector of the numerical attributes and imputer.
Sir, is the old data frame selector is F capital there?
Yes, you're very correct. That's what I was just going word by word. I knew somewhere is a problem of spelling. Okay. Once again, it is, since I have taken old data frame selector here also, I need to change it to caps because it will call the same function. Oh. Attribute name is not defined. The same first line, it tells me the error. Old, 1 second, it's some small
So
mistake.
here, self dot attribute name ATTRIBUTE. We missed
Where,
there.
where?
Before 63. Before
Before,
63, we have this. No, sir, last line.
yes,
Return maybe there.
attribute. Oh, attribute name, and here, sorry, it is not name, it is names. Attribute names is not defined. 1 second. Transform self and x, return x, self dot at attribute underscore names dot values. Okay, that's, and some error is being carried forward from here. Self dot attribute underscore names is attribute underscore names, and define fit self x and y as none. Okay,
So
and return self. Yeah,
before name that you have defined it right over there, you have it must be
Yes, sir.
attribute
Def
underscore
in
names.
itself attributes name. Then down we wrote self attribute names.
where
Yeah, either
this
it should
one
be attributes
Yes, sir.
underscore names or attribute names.
attribute. No, it is attribute names. 1 second. The top here, this is attribute names. So attribute names is attribute names. Okay, now let's. Yeah, now it's fine. Some. Now it gives me, okay, that this is, I'll tell you why. Because this old category pipeline, we have done it for this cat encoder. See, instead of with this cat encoder, before this, I need to specify my selector, which will be nothing but my old data frame selector of category underscore attributes and this category encoder. So attribute names again, some.
F there. F capital. Old data
Oh,
frame.
yeah, old data frame selector. Yeah, that's fine. Yeah, now it's fine. See the result, what you get. See the problem is not of the syntax. The problem is some small thing here and there. See here, the what result which you got is more the same as what we got in column transformer earlier. So you may write this and then let's proceed ahead. Let me know after you've done it.
Yes, sir. Let's continue.
Okay. See, for now, what we have done, we are ready to select and train a model. And I would say wonderful news is that we should be thankful to all the previous steps. Things are now going to be much more simpler than what you would have thought. What we will do, we will first start off by training a linear regression model, like which is the most fundamental thing in any of the machine learning problem. The most fundamental is linear and then logistic regression. It's like the kindergarten in a school. So we will start off by training a linear regression model. So I have to first, what I need to do, I need to import linear regression. From where? From sklearn library. So I'll say from sklearn dot linear underscore model import linear regression. Yeah. After this, what I do, I'll create a model of this. I'll say lin underscore reg is nothing but my linear regression. This is my model. Now what I need to do, whenever you create a model, you have to push in all your data into the model, whatever model you created, so that it takes care of all outliers, all those things. So I say lin underscore reg dot fit of my housing prepared and my housing label. That's it. This will help me push in all the data into the linear regression model. LABELS. Wait, housing prepared. House linear underscore housing prepared. LABELS. Housing labels is not defined. How come? We have defined housing labels. Without defining housing labels, how did we reach till here? Just let's see. Housing underscore label. See, we have defined in 13. Okay, so this gave me error here. That's why when I execute, uh, uh, 1 second. This says housing label is start. 1 second. I need to little bit go back and see what it is, because good that it see it gave me error. That's why I'm not able to execute and proceed anywhere further with this, because at that time itself it told me there is some error. So here, after we do the scatter plot, we take the median housing value. We take the median housing value sorted housing. No, we have described this. Then after this, where did we? 1 second. It's the scatter plot which I've described. Okay, this 5560. Okay, let me get into that mood of where we were doing it. Then I've described my data set. Then thereafter we went ahead, we found out the correlation of this data set. We created the correlation matrix. I used a simple imputer somewhere here. Yes, simple imputer is here. So this where I am facing trouble is before this. This is where I have taken this median house value along the axis, that is along the column. That is, this was when we prepared the data for machine learning algorithm. Okay, so I say my strat train set median house value dot strat train set is not defined. Okay, it says here I have defined this strat set. So I have to now, this says I have to define my strat train set. Are you guys also getting some error somewhere? Then how, if you're getting error, how will you proceed? Yours also would have come to a standstill. You cannot proceed if you're getting any kind of error anywhere. This says my strat train set is not defined.
So
So
can we check a little more up before 78? Like
I
maybe
think
there
there
is
is
some.
somewhere. One second, I'll have to go all the way from first. Here also there is a error. NP is not defined. Okay, that is not a problem. Okay. Yeah, now my strat train set is fine. 90. Yeah, now it's fine. At most of the time, what happens when you write program, you encounter some error, you spend days after days just hunting for the error. Where is the error? Perfect. It tells me it is linear regression. Very fine. We have come bang on where we wanted. Now what we will do, we will try the full processing pipeline on a few instances. How many instances? I'll just take 5 instances, for which I'll say sum underscore data is nothing but my housing dot index location, which I take only 5 values. I would also say, since I've taken some data, I'll say sum underscore labels is my housing underscore labels dot index location of these 5 values. Then I would say, let me create a full pipeline of the sum data prepared. So I'll say sum data prepared will be nothing but the full underscore pipeline dot transform of this sum underscore data. Now we will print out the predictions, what prediction we are doing. So I'll say print, we will say my predictions, which is nothing but my lin underscore reg dot predict of this sum data prepared. Let's see what is the prediction it gives us. It gives us all these value. Now we have to compare this against the actual value. How will I compare it against the actual value? I would say print of labels, which is nothing but the list of some labels. That's it. This will give me the actual value which it is. Now I have got the actual value and the predicted value. There is some slight amount of difference in them. So you can kindly write this. So we go ahead to with what we are doing.
It's 15 hours.
Fine. Now what I'll do, I'll just call back this sum data prepared and see what is the value I'm getting. So I'll say my sum data prepared. So when we call this, I'll get an array of all these numbers. Fine. This is just for the understanding part of it. Fine, have you done it?
Just a minute, sir.
Kindly write some comments also when you write this so that next time when you open it, it's comfortable for you. Sadaf, have you completed?
Yes, sir.
Okay. Now, see what we will do. See, we will go ahead and measure this regression models. See, linear regression is a regression, not a classification model. We will measure this regression model's root mean squared error on the whole training set, and how I will be using the mean squared error function. So using this mean squared error function, which is a part of the scikit-learn, we will measure this root mean squared error of this linear regression function. So what we will do, we will first import this mean squared error, which is also a part of sklearn. So I'll say from sklearn dot metrics import mean squared error, and we do the housing prediction based on this. So I'll say my housing predictions will be nothing but lin underscore linear regression dot predict of this um, housing underscore prepared. Now we will find out the mean squared error. Thereafter we find out root mean squared error, because it is nothing but the square root of mean squared error. So I say lin underscore mean squared error, which is nothing but mean squared error of this housing underscore labels and housing underscore predictions. Now, this will give me my linear models, linear regressions mean square, no, linear regressions mean squared error. So when we run this, we should get mean squared error. Yeah. Now we'll go ahead, find the square root of this. That will be the root mean squared error. So I'll say lin underscore RMSC will be nothing but, it's a numpy function, square root. So np dot sqrt of lin underscore MSC. Now, when I call back my lin underscore RMSC, I should get the root mean squared error, something around 68,147 or whatever. Not accepted, because if you see the housing data set, the median housing value ranges between something, I think it is 1,10,000 US dollars to something 2,50 or 60,000 US dollar. So a prediction of around the $68,147 is not at all satisfying. This means this data or this model is underfitting the training data. So when this happens, it can mean that the features do not provide enough information to make good predictions, or that our model is not so powerful enough. So we will not use this linear regression model. We will use a decision tree model. We will calculate the same thing using a decision tree model. We do the same because what I want a wonderful accuracy. So what I'll do, I'll use a decision tree model to calculate the same lot of things. So for which what I need to do, first I need to import the decision tree regressor. So for which I would say from sklearn.tree, I will import a decision tree regressor. And then I would say my tree regression is nothing but my decision tree regressor, say with the random state which we have been stating all throughout as 42. We call the same random state. And what now, since this is the model I have prepared, we know it, I need to push in all my data into this model. So I say tree underscore reg dot fit of my housing underscore prepared and also my housing underscore labels. So when I execute this, it will tell me it is a decision tree regressor with a random state 42. Now we get into finding the mean squared error and the root mean squared error using this decision tree. So I would say my housing underscore predictions is nothing but my tree underscore reg dot predict of my housing underscore prepared. Now I would now go ahead and find out the mean squared error. I would say tree underscore MSC, which is nothing but mean squared error of my housing labels and my housing predictions. Now we know how to find out the root mean squared error. It is just the square root of this mean squared error. So I'll say tree underscore RMSC will be nothing but np dot square root of tree underscore MSC. Let me call my tree underscore RMSC and see what is my root mean squared value. Oh God, I am getting 0. So can Saida help us and tell us what do you mean when you get a root mean squared error value using decision tree as 0? What does it imply? Tell me, Saida, what do you imply by, what does it imply when I'm getting a root mean squared error value of 0? What does it mean? Try. See,
Maybe we
unless you
don't have any error.
Oh, cannot be. See, this means
Values
that
are
this is a
same.
really, sorry, Sadaf?
The values are the same.
No, this means that what you're getting is an ideal model, very, very ideal model. Or it can mean that these values are extremely overfitting the data. There is something. Now, see, it can either mean that this is an ideal model or it can mean that it is really overfitting the data. But I don't want to presume anything because we are not an astrologer or a numerologist. We will ask Python to help us out. So what I need to do, I need to fine tune the model just to understand whether is it that this is an ideal model or is it that this is overfitting the data. So to fine tune the model, I have to call for the cross validation score. We will import the cross validation score and we will do a cross validation of 10 times. Do you know what do you mean by cross validation? Sadaf, Saida, anybody? Do you know what is meant by cross-validation? Tell me, whatever comes to your mind, you can tell me, don't worry.
So validation means to just check if it is correct or not. So maybe cross
That is
verify.
validation. The correct, what you said is validation. I'm asking you, what do you mean by cross-validation? Well, then what is cross-validation? Okay, see,
Cross-checking it with yeah, sir.
yeah, correct. Tell us. Continue, Saida.
No, cross-checking it with some already validated data, maybe. That.
See, never should you say maybe. Once you say maybe, you're a numerologist or astrologer whom you find in some mall or other thing who runs the risk of getting thrashed by the public. We are not numerologists or astrologers. We are data scientists. We predict using only statistical models. See, cross validation is a resampling procedure which is used to evaluate any machine learning model on a limited data sample. And this procedure has a single parameter called K that refers to the number of groups that the given data sample is to be split into. And as such, the procedure is often called, generally it is called as k-fold cross-validation. So what we will be doing, we will be using cross-validation value of 10, because ideally what you find whenever you take this value of 10, it is more or less fine. You get good results. See, which experience is. We will go by what big people have worked on this. Why should we reinvent the wheel? We are not going to tell how many cross validation, whether it is 10 or 20 or 30. A lot of people have already worked on this. They have told a cross validation score of 10, but this value becomes changes for each problem. Please understand, when you give a high cross validation value, the program gets very sluggish. It takes a very long time for it to complete execution. On the other hand, if you give a cross validation value of very low, means 100% your answers are gone, it is wrong. So you have to specify the optimal cross validation score. And since there are many great people in the world who have worked enough and told it is better around 10 you give, it should be fine. So we will take what their thing is, because we see the breed of data scientists are the smart people. They don't want to redo the thing what somebody has already done. When they have done it, we just take we just follow whatever these guys have done. So what we will do, we will fine tune a model importing this cross validation score, for which I'll say from sklearn dot model underscore selection, I will import cross validation score. And this scores, I define another variable called scores, which will be my cross val score of my decision tree. I'm using a decision tree. I told you sometime back, decision tree dot reg, and my housing underscore uh, prepared, and also I will call my housing underscore labels. And here my scoring, what I would say, will be nothing but it will be negative mean squared error. Negative mean squared error. And I have to also specify my cross validation, which I'll say is 10. This thing we can evaluate and see. Okay. Negative, oh, this is mistake in what we have done. S is not capital, S is sentence case. So we are doing a cross. See, 10 times this model has to execute. That's why it's taking little bit of a time. Now, after this, we will find out the root mean squared error scores of what we are doing when we are fine tuning the model. So I would say tree underscore RMSC underscore scores, which will be the square root of np.sqrt of this negative scores. So when we execute this, okay, fine. It is because I'll tell you why. This because we jumped this. Okay, now you find it. Now you say tree RMSC underscore scores will be the square root of negative scores. Execute this. Perfect. So now we have found out the the decision tree root mean squared error scores. But now if I just call back this course, let's see what I get. I call back this course. oh, something of this kind. This is of just no use to me. I want the scores to be displayed as scores, the mean, and the standard deviation. So what I will say, I'll define a small function. I'll say define display underscore scores of my scores, which will be where I will print. I'll say my scores is nothing but my scores. And as well, I would also say I will print my mean, which is nothing but my scores dot mean. And scores dot mean, I need to open close my brackets. Then I would also print my standard deviation. My standard deviation, which is nothing but my scores dot std open close bracket. That's it. Now when I call for to display the scores, let's see what I get. I'll say my display underscore scores of this tree underscore RMSE underscore scores. So when we execute, now I've gotten a wonderful way. I can very well comprehend the result. I say my mean is 70,789. Earlier, how much did I get as my mean? It was, where is this mean gone? We had got a mean of, where is, yeah, fine. My mean now I'm getting is 7789. Now we will see if we can improve upon this mean. So we will improve upon this mean value because we have to get it somewhere close to 50,000, because that is where the median housing values range resides. So you may kindly write this. In the meanwhile, let me take your attendance. You can kindly write this. I'll not go off the screen, don't worry, so that you are able to do your thing, whereas I'm able to do justice. One second, let the attendance sheet open up. Yeah, 63956, 733008, 733054, 733056, 733075, 733076, 733084, 733095, 737010, 737020, 737023, 737024, 733001, 733005.
Present, sir. 001.
Okay. 733005, 733007, 733008, 733009, 733009, 733010, 733012, 733013, 733014, 733016, 73314.
733014 present.
4%. Okay. 733017, 733019, 733020, 733021,
Present, sir. 021.
733022, 733023, 733027, 733028,
Present, sir.
28%. Okay. 733030, 733031, 733033, 733035, 733037, 733038,
Present, sir. 39.
39%. Okay.
Yep.
733041, 733042, 733044.
Present, sir. 41.
41%. Okay. 733044, 733053, 733054, 733056, 733057, 733058, 733059, 733062, 733070, 733074, 733077, 733080, 733085, 733086, 733002, 737001, 737004, 737 your 4 is present.
Yes, sir.
Okay, 737008, 737009, 73713, 73714, 73715, 73716, 73717, 73719, 73720, 73721, 73722, 73724, 73725, 73727, 73728, 73729, 73731, 73733, 73744, 73739, 73740, 73742, 73744, 73746, 73752, 73753, 73302, 73303, 73304, then 73307, 73308, 73311, 73312, 73313, 73314, 73314 is absent, 73321, 73324, 73325, 73329, 73331, 73334.
Present, sir.
Yeah, okay. 73335, 73335, 73336,
present, sir.
73337, 73338, 73345, 73347, 73356, 73357, 73361, 73363, 73364, 73365, 73366, 73367, 73368, 73369, 73371, 73372, 73373, 73374.
Present, sir.
Okay, 73375, 73380, 7338081, 7338083, 7338088, 7339094, 733104, 733106, 733 733 absent, 733 73301, 73302, 73303, 73304, 73304 absent, Syed Ahad absent, M.A. Atif, Mohammad Azhar, Asra Amreen, Mirza Asif Beg, Safi Faruqi, Syed Musa bin Hafiz, Riyan Hashmi, Syed Inayat, Nihal Khan, Syed Madani, Abdul Mubin,
Present, sir.
Syed Mateen, Abdul Mujahid,
Present,
Syed,
sir. Present.
Syed Numan, Mohammad Qadir Qadri, Syed Shabazz, Sana Sultana, Rutherford Thompson, Saifuddin, Mohammad Zainuddin, Abdul Basir, Syed Muttalib Ahmad, Abu Ansari, Mudassir Muhammad,
Present, sir.
Faiz Qadri, Sheikh Shoaib, and last Syed Shah Zohaib. Wonderful. See, since we are at the end of the time, I can only tell you, see, of the people who were present here earlier, that is of Sayada and team, please do one thing, work on this problem which I told you of Zomato, Swiggy, whichever. Try solving it. If you can do it, it's great. Because just yesterday and day before yesterday, I sat till very, very late in the night, I could solve it. And wonderful result. We will do it tomorrow, not tomorrow, Sunday. One of you give me a tinkle, maybe somewhere in the afternoon on Sunday after 2-3 o'clock. We will sit together and we will do it so that it gets comfortable for you, so that you understand how do you solve a practical problem. Otherwise, till this, what you're doing, it all remains on the book. In any case, this one is also a practical problem. We are predicting the house prices of those houses which are along the seashore in California. And the data set is a true data set what we are using. Although it's not very big, it's a true data set. So kindly try doing this. If you can do this Zomato, Swiggy ka problem, it's great. If you can, you will know how do you handle any of the live problems of this kind. Okay, has anybody got anything to ask me? If you have got, please ask me. Otherwise, we wind up the session. Okay, fine. Thank you. Have a nice day. We'll meet up tomorrow at 2:30. Thank you. Have a nice day.